Hi guys, in advance to this video, I just want to apologize for the quality. I am not a very tech savvy person and I didn't really have anybody that could help me. Anyways, I hope you enjoy what I have to share. Alright, let's jump into it. So today I'm going to be teaching you Chapter 2, Section 1, Frequency Distribution for Organizing and Summarizing Data, and my name is Laurel Yoakum. So what you may be asking is, what is frequency distribution in the first place? A frequency distribution or frequency table shows how data are partitioned among several categories or classes by listing the categories along with the numerical frequency of data values in each of them. And this is what a frequency distribution table would look like, as you can see right here. All right. So there are several things that you are going to look for in a frequency table, and one of those things is the lower class limits. So you may be asking, how do you find the lower class limits and what are they? The lower class limits are the smallest numbers that can belong to each of the different classes. So how you would find the lower class limits of this particular frequency table, you would look at this side where the age is, and you would see the smallest number of each class would be 0, 10, 20, 30, 40, and 50. Again, that's how you would find the lower class limit, basically just by looking at the smallest numbers that belong to each of the different classes. Next, we are going to be discussing how to find the upper class limits. The upper class limits are basically the complete opposite of the lower class limits, and the way you find them is also the opposite as well. The upper class limits are the largest numbers that can belong to each of the different classes, and for this particular frequency table, the upper class limits would be 9, 19, 29, 39, 49, and 59. And basically, if you want to find that, you just look at the largest number of the classes. And that's easy because you just see that, okay, the largest number in the first group is obviously 9, the largest number in the second group is obviously 19, 29, 39, etc. And you could do the complete opposite for finding the lower class limit, which would be 0, 10, 20, 30, 40, and 50. All right, let's move on. Now you need to discuss, what are the class boundaries? The class boundaries are the numbers that are used to separate the classes but without gaps created by the class limits. So you may be looking at this. The class boundaries aren't exactly clear and they don't exactly jump out to you. So you kind of have to do the work by yourself. So you would look at the first class and the second class and you say, okay, I need to look at the upper limit of the first class and the lower limit of the second class to find my first class boundary. So we know that the upper limit of the first class, which is 9, and the lower limit of the second class, which is 10. So now we need to figure out what number is exactly in the middle of that. And so that would be 9.5, and then you would complete the same process for the following one, which is what number is between 19 and 20, and that would just be 19.5, and you keep completing that process until you get all of the class boundaries. So the class boundaries for this particular frequency table would be 9.5, 19.5, 29.5, 39.5, 49.5, and 59.5. Now we are going to be discussing, what are the class midpoints? And when I first started learning this, I kind of got confused between the class midpoints and the class boundaries. So a way that I differentiated the two is, boundaries is just kind of simple. What number is the boundary between each of the classes? And that's easy, it's 9.5. And then for that, we're going to do the class midpoints. So now we are looking at the class midpoints of the values in the middle of each of the classes. So what midpoint is exactly in between each of the classes? And again, this is not a number that is going to be jumping out to you. So again, if you look at this frequency table, you can see that the class midpoint for the first class would be 4.5. And I know that number is not clear on the table, but if you just ask yourself, okay, what number is exactly in the middle of 0 and 9, and that would be 4.5. And you complete that process for the rest of the classes. So again, for the first class, the class midpoint would be 4.5. For the next class, it would be 14.5, because 14.5 is the midpoint between 10 and 19. Again, you would complete that process for the third one, and that would be 24.5, again 34.5, again 44.5, and finally the last class midpoint would be 54.5. Okay, let's move on. Finally, we are going to be discussing what is the class width. Now, the class width honestly confused me a little bit at first, and I would always get the incorrect answer, but going over it multiple times with practice, I was able to make clear to me what exactly the class width is looking for. So the class width is the difference between two consecutive lower class limits or two consecutive lower class boundaries in a frequency table. So you may be looking at this and be like, oh yeah, the class width is 9, because what's the difference between 0 and 9? That would be incorrect, because you're not looking for the number that is between 0 and 9. You're actually looking for two consecutive lower class limits, and you can pick any of them, but I think what is the easiest to do is just to do the first two. So let's find the two consecutive lower class limits. So let's see, 0 and 10. So then basically you just find what is the difference between the two, and that's easy. That's just going to be 10. For this frequency table, the class widths is 10, and you can also do it with two consecutive lower class boundaries. Like if you wanted to do the class boundaries for the first two classes, you can do 19.5 and 9.5, because those are the first two consecutive lower class boundaries, and 19.5 minus 9.5 would again give you 10. So a common mistake that is made with class widths is people think, oh, the class width, again, I'm just going to be looking for what is in between 0 and 9, which is false. You're actually looking for two consecutive lower limits. All right, let's move on. So again, I'm just going to give you a visual representation of how to find the class width. So then you get a maximum data value and a minimum data value over the number of classes, and that is going to equal the class width. And I can actually show you that here. Sorry, let's go back. You're going to take the maximum class value, which is 10, and the minimum, which is 0. So 10 minus 0 is 10, which that is going to give you your class width. All right, let's move on. So now we're going to be asking, what is relative frequency distribution? So a variation of the basic frequency distribution is a relative frequency distribution or percentage frequency distribution, in which each class frequency is replaced by a relative frequency or proportion or percentage. That being said, the sum of percentages in a relative frequency distribution must be very close to 100%. This leaves very little wiggle room for rounding errors. Again, it is vital that you get your relative frequency distribution numbers close to 100%, or you're going to have a lot of room for rounding errors, and this leaves very little wiggle room. All right. So now you may be asking, how do we find relative frequency? To find relative frequency for a class, you divide the frequency for a class by the sum of all frequencies. But to find the percentage for a class, you divide the frequency for a class by the sum of all frequencies and multiply that by 100. Again, I'm going to show you guys a little equation. It's just worded a little bit differently, but don't worry, I'll explain it. So in this equation, it says relative frequency is equal to the number of successful trials over total number of trials. And again, that's just when you divide the frequency for a class by the sum of all frequencies. So the number of success trials is the same thing as frequency for a class divided by the total number of trials, which is a different word for sum of all frequencies. Okay, let's move on. Okay, and now we are going to be discussing cumulative frequency distribution. Another variation of frequency distribution is a cumulative frequency distribution in which the frequency for each class is the sum of the frequencies for that class in all previous classes. And here is an example of that. So you got the sum, and then you got the frequency, and right here, that's when you would plug in the cumulative frequency that takes the sum of these and just inserts that information right to this third section. Let's move on. Okay, so now you may be asking how to use frequency distributions to understand data. So in statistics, we are often interested in determining whether the data has a normal distribution. And in order for data to have a normal distribution, there's a couple things that must be met and guidelines that are in place. So the frequencies must start low, then increase one or two higher frequencies, and then decrease to a lower frequency, and the distribution is approximately symmetric. Frequencies preceding the maximum frequency should be roughly a mirror image of those that follow the maximum frequency. And I'm going to be showing you what a normal distribution table may look like. So here we have all of those guidelines that I just explained to you are perfectly met in this normal distribution table. All right, that's all I have for you guys. Thank you so much for listening, and I hope I was able to teach you something. Thank you.